They just don't show.
It should now be. They're showing on my screen, so they're there. They're not going to show on your screen.
Gotcha. Welcome. Thank you for coming. This project is a big deal to us, and we finally worked through the contractual agreement process with the DOE representatives by October 1st of last year. And so we've started into the first couple of months of managing the schedule of what's the better part of a 5-year project. The contract and the agreement has expectations and requirements about community information sharing, community communication, public meetings, making people aware and getting questions, getting input, getting concerns, and being able to have a dialogue. So under the contract, we're supposed to have 3 of these in the first year and then 1 each year thereafter. With the rapid pace of the reaction to the president's executive orders and the pause on federal funding and a lot of the direction that's coming out in the last day or two related to federal grants and federal programs, we could have canceled this meeting just because of that confusion, but I think it's a priority for us that we're not seeking public input or community involvement because it's a check the box requirement of this DOE project. And so it's really important for us just to have a dialogue and see who's interested, who has questions, and who can we engage in the coming months related to the project. So the format here, I think, is pretty informal. Chris Selstrom, our Deputy General Manager of Electric, will give me an estimate, 15-minute, 10 to 15-minute overview of the project itself and what we are planning to do and kind of what order we're doing that. And then we'll just turn it over to a dialogue. I don't think we're going to treat this as a formal, you only get 3 minutes or you only get 5 minutes and we won't respond. I think that appreciate you coming and we'll treat it as hopefully manageable, that we can get some questions out there and respond. And if we don't have the answers today, we'd be happy to follow up in the weeks ahead. So, Chris?
So we got, as Dave mentioned, we're an awardee now. We've been selected with the selection process. Now we've gone through the contracting process. Now we've been executed contracts. Now we're an awardee, which is an exciting step forward. So the total federal cost share is $17 million. Our local cost share is $5 million, about $23 million project overall. Pretty significant undertaking. I'm pretty excited about it. So we get this probably all on that slide. So this is our project team. Brad Bentley in the back. He's our principal investigator. He's in charge of interacting with the DOE probably on a daily basis right now. Corey Allen's our power plant supervisor. Mitch Simmons is our senior power system electrician. So they're focused more on the technical side of this. How do we build it? How do we install it? Where does it plug in, essentially? Alan DeTanto is in charge of all of the competing engagements. So thanks for setting up today and making sure we found our way here. My signage. Amanda and Jarrett are both on our transmission distribution team. They're going to be focused on the underground infrastructure, the downtown improvements, some of the things that will go into the electric distribution system. And then Becky and Dave are both here. Becky is our communications coordinator who got the message out. Wow. So that's everybody on there. So the main point is community reliability and resiliency. Those 2 words are kind of interplayed sometimes. Reliability is the potential to not have a problem, and the resiliency is if you do have a problem, how do you recover from it quickly and effectively and efficiently. So there's a whole bunch of reasons for this. Public safety is an important thing for us. We want to make sure our community has electricity is becoming an essential service for the community. It's important for economic growth and stability. So we want power. We want power to our public services. We want power to our vehicles and our transportation networks. We want heat in the wintertime too. So pretty important. Electric bill charging, I think I mentioned, jobs and unionized labor. We have a great workforce. And then electrification decarbonization is another component here as we move toward electrified future. Energy storage is going to be important. That is important for not only reliability, but also economic value. We need to move that energy that's being created in times that we're not necessarily needing it so that we have it in times when we do need it. So the microgrid itself, what that really means, I think the next slide maybe. Okay, well, I guess I'll do this. So some essential services that we're going to provide and the total project area. But I think the next, okay, maybe it's two more. Forgot the order of these, sorry. All right, so I'll just jump into this one real quick and then go back one. But right now we have a power plant that's located downtown. The power plant is a really big generating asset. We can put about 80 megawatts onto the grid right now into the whole grid is all interconnected. The power plant right now does not have the capability to run by itself. If we lose the connection with the broader transmission network, kind of this over here, over in Dow Street, we don't have power. There's no way to run the power plant today on its own. So the purpose of this project will be to add a large battery pack to basically jumpstart the power plant. That battery pack is over 3 megawatts. It takes a lot of power actually to start a power plant. It'll start the power plant. It'll get the gas turbine online. The gas turbine will put about 40 megawatts. That's what we're calling our core system. That 40 megawatts is about 15 minutes to get online. So pretty responsive. So if the entire eastern seaboard is the example that went down a decade or two ago, or an ice outage or wind outage that takes out the transmission system, we could turn on the generator, turn on get about 40 megawatts out of the system. The battery also will supply some voltage and frequency support to keep the grid stable. You need some of these other services like voltage frequency. From there, it's fed from underground cables. So the power plant not only generates power, but it also serves as a distribution system, a distribution center for the western part of the system and the downtown area. So there's a whole bunch of underground circuits that come out from under the power plant, and they feed all the businesses in these downtown areas, and also some distribution substations. And in some places, they pop up and go overhead, so you'll see them above ground as well. So those distribution circuits will be, they're storm resistant, right? They're underground. They're not going to be impacted by ice, wind. They're pretty secure. So that's what we're calling the core network or the primary network. And the gas turbine has enough capacity to serve that entire network. So it'll include the hospital, include City Hall, most of the businesses in the urban core here, 2nd Street up to 5th Street. There's a few businesses in between that have some overhead lines, but pretty much the urban core. So 3rd Street Bridge over to almost Prendergast here in that block, as well as underground to the regional hospital, to UPMC, and also some underground to some distribution substations. So out of the Dow Street, or out of the power plant here, we also run underground to some of the residential distribution substations. Regent, Steel is a few of them. You'll see them small buildings out there with large transformers. Depending on the nature of the problem, so if the aerial network isn't damaged by ice or wind, so say this is a regional voltage problem or like a rolling blackout or something that's caused on the transmission side, but our overhead local network is still intact, then we could feed some of that aerial network as well, and we could dynamically expand the scope of the coverage area, which is a really interesting piece of this. Most microgrids are set up on a building level, right? Now we're talking about a community level that can expand and contrast depending on the load and the generation. So it requires a lot of technology to make that all happen. We're still trying to scratch our heads and figure out how to make that work, but we're pretty excited about it. Another component, there is some distributed energy. So there's some battery storage we're going to deploy out here. The batteries are pretty cool because that was an idea that came out of a public meeting like this. When we looked at the overhead, we were focused on the electric side, and some of our district heating customers in the first meeting said, well, what about district heat? We're fed overhead, but we have access to this hot water, but we have no way to pump that heat around our buildings because we would be out of power. So we actually worked in some battery storage to facilitate running the pumps in the buildings that are electrically connected to the overhead network, but also have district heat. So there'll be some batteries, the distributed batteries that will go in. And then all of the batteries, the distributed batteries and the central plant will be economically dispatched during the rest of the time. So we'll be able to use that for grid services and create revenue to support the ongoing maintenance of that equipment. There's also some funding for some electric vehicle charging stations. They'll look a lot like the ones that we already have deployed. The main difference is they'll be set up to connect to the underground network, so they won't be exposed to the aerial overhead. That way, that if we do move forward with electrification of our fleets, whether that's police and fire or utility or consumers, we'll be able to charge our vehicles locally in a regional route. So I know that's a lot in that slide, but I think it's helpful. So we can go back and get some. So some of the businesses, the community services, the regional hospital, shelters is always important. Schools, so the local high school here is on the underground network, and some of the middle schools nearby are actually on overhead networks that would be in that first layer of pickup, depending on the load. All the businesses that are on the underground network downtown. So about 9,000, 10,000 customers depending on the load. And then it'll vary dynamically depending on the season. So, the winter time, the coldest time of year is where our load is the highest. We can push our equipment a little harder that time of year, so we can still pick up quite a few people. Spring and fall, the load is the lowest, so we can actually go quite a ways, almost our entire system. And we can even look at after the gas turbines about 40 megawatts. If things are looking like it's not going to come back for a few days on the regional system, we could actually turn on the steam system, which takes almost a day to turn on. But once that's online, we've got another 40 megawatts to continue to expand the load outward. So I think that's it on that slide. So regional, some other greater state and federal benefits. I think that was helpful in us getting awarded generation and grid flexibility. As you get more renewables on the systems, the solar and the wind, those produce power when those resources are available, like when the wind is blowing and the sun is shining. They're great additions to the system, but we need power all the time. And a lot of the times we need power when the sun isn't shining, particularly those cold nights like tonight when it's chilly out and the sun's not out. So adding battery storage, adding dynamic response, potentially adding frequency and voltage support to the ISO as a potential market opportunity. That's something we're going to explore the potential to do. Regional resiliency obviously is important as well.
Done with that one?
Yeah. So just kind of a map of the coverage area. The coverage area will be done by a circuit basis, so it doesn't always exactly overlap with a map. There will be customers in these shaded areas that maybe are not connected because it just happens to be how the circuits are run. But this core network that I mentioned, the underground, we're over here in City Hall, the power plant's down here. Pretty small picture, but you've got the hospital, you've got some commercial buildings here through downtown, as well as some other medical buildings. And then zooming out a little bit, this yellowish color is the west side of the system. This is the part of the system that's fed from the power plant distribution. So that would kind of be that second layer of the network. The east side is all this gray. This is actually fed on a substation. So it's a little harder to get power that direction. But if the outage is big enough and long enough and we have enough generation capacity, we could look at restoring power to actually the entire community. So it's one of those, like, it depends answers, but it's pretty significant. Any questions on anything so far? Just kind of run the line here. Okay.
You're gonna have questions afterwards, or should we ask?
Whatever. Yeah.
Dave mentioned the moratorium or hold on the federal money from DOE. My understanding is that the DOE money specifically is going to have a real watch aspect. The DER applications are going to be specifically targeted as not fundable. So what I'm saying is this, is that the local share, you're not spending any of the local share money until you're sure that you actually have this particular $17 million in hand.
Yeah, and you spend them in parallel as you go. So every time we spend something, we get reimbursed and in tranches.
Where is the $5.2 million coming from?
Our electric budget.
What effect does that have on the existing ratepayers?
It should have minimal impact.
Increase?
Yeah, I mean, like the underground network, for example, the 1970s, 1980s, 1970s cables all ended life. We got to replace that anyways. So where we were going to spend $4 or $5 million replacing those cables over the next 10 years, now we get 7-to-1 or 4-to-1 match, replace all that infrastructure. So it's a pretty good deal.
The best component, which you know what that is, don't you, BESS, that battery energy storage systems, that you're talking about, when you talk about district heating applications with the batteries, usually the BPU responsibility ends at the meter. Are you gonna own the batteries inside the buildings?
Yes. At least for the performance period of this grant. We haven't contemplated the handoff at the end of the agreement. The short-term answer is yes.
So what protection mechanisms are you gonna have in place for the lithium ion storage application?
Yeah, I mean, we'll have to look at all the fire code and make sure they're installed in locations. And
But they'll be inside the building or outside?
yeah, these are the distributed ones are small. Those are like 15 kW. You know, they're not very big. They just need to run the pumps in the buildings. That's all they do.
I wouldn't consider those BESS.
No.
Yeah.
Well, it depends on what the sizing requirements are.
Yeah, most of
I
these,
mean, you're gonna
most of
do
these,
a best at the plant.
the best of the plans is much
Correct.
different.
But what you're talking about is not that.
And the big battery, the power plant, that'll have all built-in fire suppression. It'll be all isolated. And there's a bunch of design standards. And the distributed stuff are small. They're wall-mounted things. You can put it. That's the power walls and things like that. So much smaller scale.
I have more questions, but I'll wait till you're done.
So it's kind of the quick timeline. So this year we're working on engineering, procurement, and the public outreach. Hopefully this Q2 this year we'll start digging up some roads.
Just wondering if you have any other technologies related to, is battery only your technology that you're looking at, lithium ion? Or like, some places are looking at using hydrogen or other sources for storage.
Yeah, so this is focused on batteries, chemical batteries. Lithium ion is one chemistry. We haven't formally decided on which chemistry we're going to use. So that'll be designed during the design process to pick the chemistry. But it's focused on batteries for a couple of reasons. One, the scope of this project is small when you start thinking about like a hydrogen plant or creating a hydrogen process. That's a much bigger investment. And it's not quite there yet, is the problem. This leverages our existing technology. It's a very fast-acting resource. It can handle the voltage, the frequency dynamics. You can size it within our existing power plant footprint, which is really important, and leverage all those existing investments we have. Eventually, hydrogen is something we're definitely looking at. We did travel down to Brentwood, down in Long Island, when they did a hydrogen test on a gas-fired engine, the Lone 6000, which is the same exact engine that we have. And they managed to get up to 30% injection of hydrogen right into the existing unit. But they were pulling at, I think it was, I might get the number wrong, but I think it was like 7 or 8 tankers a day. Or was it a day? This is sure. It was some ridiculous amount of trucking that was required to move the hydrogen, and they could only run it for a few hours because they consumed the whole supply. There's not enough hydrogen production yet.
There's green hydrogen.
I don't even think it was green hydrogen. I don't think they could buy enough hydrogen to support the plant. I mean, the scale that we're talking about, we start burning. When you're looking at the volume, hydrogen production is nowhere near. It's just not significant yet. But it's definitely something we're keeping an eye on. And we are doing a study with EPRI looking at hydrogen pyrolysis to actually take and make. I think it's teal hydrogen is the color. There's always colors for hydrogen.
Right.
But you pull apart the hydrogen from the natural gas, and then you can store the carbon and use the carbon for fertilizer and things like that. And then use the hydrogen for injection into things like district heat boilers or.
Because then that makes natural gas something to keep around as opposed to
Exactly. Yeah.
getting rid of it. Yeah.
Yeah. So we are exploring that. We're also exploring some other technologies that are more long scale duration. Batteries aren't really scalable in that way. If you want longer duration, you have to add more batteries. If you want more capacity, you got to add more batteries. So we are looking at some other technologies that have longer duration, but nothing currently seems to be at market readiness for a community that our size to invest in. So year 2, construction begins. Hopefully we'll start with the smaller batteries, work our way outward. Software, I didn't mention software in this, but software is actually a huge component of this whole project. We've been working to digitize our entire distribution system. We now have a digital twin of the entire electric system, so we can model what's going to happen and how things are going to behave. And we have to take that to the next level with this. Now, not only do we have to predict what's going to happen, we actually have to take action in real time, because the electric grid doesn't have inertia. It's on or it's off. So it requires a really interesting coordination on a real-time basis to keep everything online without all that inertia connected to the national transmission system. if we're running on our own, we've got a little bit of engine and you don't want it to stall. You also don't want it to spin too fast if there's not enough load. So matching those two in real time is going to be interesting. And as well as isolating breakers and reconnecting breakers, managing what consumers are out. So we're also putting in an outage management system, which will give us a kind of heads-up display of what's going on in the system in real time. Expanding that model, and also the distributed energy management system. So those distributed batteries we talked about, we need a way to communicate with them, control them, dispatch them to create economic value during normal hours, but also keep the reserves and keep it ready to go for an emergency condition. So optimizing all of those things is a really interesting software piece that will be layers of software together. So yeah, 3 and 4, a lot of construction, underground cable replacements. So I mentioned, I don't know if I finished mentioning, but we're going to be looking at some underground projects. Hopefully spring of this year, we'll be looking at undergrounding some actually road on Prendergast here right outside the door, as well as some First Street, probably our first two target areas. The reason for that is some of those circuits are attached to underground circuits, and we don't want to expose the underground circuits. We want the entire underground circuit underground so that there's no exposure to the whole circuit because one piece is above ground. And then we'll replace quite a bit of cable, quite a bit of the old cable I mentioned. Cable only has such a, so it only lasts for so long, so some of that need to be replaced anyways. And then by year 5, we're hoping to get testing and commissioning the system. It sounds like a long timeline when you say it this way, but it's an aggressive timeline for what we're doing. So pretty excited. And I think Dave mentioned the community meetings that we're going to have a couple this year, and at least one every year. But if there's community input, we'll do more. So that was a whole update there. Yeah, Nick.
Can you go back one? I mean,
Sure.
I think that, Doug asked a good question, right? I mean, is the 17.4 from the federal government has been our commitment, 5.8. I mean, I would think that we've been working for 8 to 10 years, looking out in our 5-year budget planning, anticipating what type of projects we're going to pursue. So I think from an electric division standpoint, we've got designated cash available to support this project without a rate increase. I think if you look at the base rate increases that we've had as an electric division, which is what we would go to the Public Service Commission for, is we had about a 2.5% rate increase in August of 2010 and about 2.33% in March of 2016. So it's not like we're increasing rates to do projects like this. I think we and all of our customers should be more concerned about our variable rate, which is our fuel adjustment charge, which is where a lot of state fees and state mandates and hydropower rate increases come, separate from what we try to control is the utility. But that doesn't mean that because we planned for that $5.8 million to support this project that we're going to start spending it if we're not certain that we're going to be reimbursed for it.
Well,
So
yeah, no, first of all, I appreciate everybody's effort in this whole application. I think I heard the initial thought was it's like a 10% chance of getting funded. So that's a pretty remarkable leverage factor. But as you know.
well, let me just finish where I was
Oh, I'm
going.
sorry. I thought you did.
No, I think that, it's not like we're in a position right now where we're going to go spend a bunch of money. I think some of the clarity on the executive order in the pause that's come out is there's going to be restrictions or the stop of the community benefits plan. So there's community benefits, outreach and objectives, or organization and objectives, the CBLU plan. I think that we expect that that's going to be stopped in some manner where our contract would be amended. I think the environmental justice part of it and the DEI part of it is all part of our current contract that we expect is going to be amended, and that's going to be stopped in some way. I think that the core part of the project, from the feedback that we've got to date, is that's going to go forward, but that needs to be proven out. So I think we're in a 90-day pause period, and each week that goes on, I think we're going to find out more about is there funding available or is there not? What's going to be stopped? What's going to be allowed? And we're pretty confident that the core components of the project are going to remain reimbursable under this whole microgrid effort. So I think we're going to continue to chip away at planning and doing the request for proposal for an owner's engineer for the microgrid components and kind of the planning for the underground, as Chris mentioned. But we're not going to be spending a bunch of money in the next 2 to 3 months with uncertainty on where this is all going to shake out. So that's kind of a little bit of an answer to your initial question.
Well, I think that's hopefully very optimistic and it will work accordingly. But there's a lot of things here that are moving toward this completion. I think that are unknowns. And what I mean by that is that the state of New York, compared to all the other states, in a current microgrid evaluation is ranked as a number C category compared to B or A. And if you want that information, I can send it to you, but
No,
it's
you
all out
confuse
there.
me with the number C.
The C is like an average. C in any kind of rating system, you have A, B, C, or D.
Gotcha.
So they're at the low end of the C scale. And in addition to that, the microgrid right now, in terms of around the states and other states, have to be subject to the IEE standards. Are you familiar with those are? Institute of Electrical and Electronic Engineer Standards, regulating the whole aspect of that, which pertains to how the system functions. And how the system functions is based on, like, I got 8 criteria here. Your initial investment costs, your complex planning and design applications, the maintenance operation complexity, that's O&M after the system is operational, which needs to be kind of like flushed out to some extent. Because as the article in the paper so stated today about the pending hydropower allocation escalations, which in fact are going to put more stress on the system. And if you have an expanded system, plus the operation and maintenance costs associated with the microgrid, it's going to have witnesses of increased costs of operating utility. There's no question about that.
I don't connect those dots.
Well, they will be
The
connected.
hydropower allocation is unchanged. It's a hydropower rating.
Well, that's, the rate increase is
And
still.
that rate increase is a pass-through to our customers. It's got nothing to do with
Well, it
our
will,
operating budget.
it will be because they still have connectivity to your grid. And they still have rate costs associated that are not aligned to the microgrid costs. Those are going to be separate phased in costs. I would assume you're not going to do this system for free. You're going to have some chargeback
This is
associated
a
with that.
project, and the hydropower is not necessarily connected to this project
It's-
at all.
But the long range picture of electrical costs is your distribution system. We have a rating, A, B, or C. You have the capacity, you have all these things in play, that you have no problem distribution wise with any of the microgrid applications. I mean, is that, we're all in good shape there? There's your delivery and everything associated with the distribution and the transmission of the existing system when you bring on the grid. Now, with the microgrid, is all this going to be dovetailed in together without any problem?
I think the short answer is yes, and it's actually going to improve the capacity we have, especially on the underground network where we're replacing cables. So we're replacing old cables that are undersized and 40, 50 years old. We're putting in new, bigger cables, so they'll have more capacity, they'll have a longer lifespan, they'll increase the distribution capacity.
Okay,
They're not adding any load either, I think that's important. There's no added load, so it's not any, doesn't sound like any additional stress on it.
Well, I think where Doug could make the point is the state Climate Leadership and Community Protection Act is focused on decarbonization. And part of that decarbonization is focused on electrification. And I think that we anticipate could have an impact on our distribution system and our interconnect with national grids. I think that is a potential load increase that we are working through and anticipating, but it's not strictly related or has anything to do with our hydropower allocation for our system.
And to add to that, this project adds value in that scenario because we would get an outage management system. We get the dynamic load rating of the systems. We can model and see where the load projection is. We can sum them at transformers virtually. I can add loads like, okay, what happens if we add 3 megawatts of heating load? What happens to our system? We can answer that question now once we've made these investments.
So your scalability and flexibility limitations are.
They're going to open. It's going to open the door for all of that.
So
We don't have that capability.
No, you don't have it, but you feel that's gonna overall enhance the existing system?
For sure. Yeah. And then also the distributed energy, the reason why we were also excited about that, in addition to supplying district heat customers the energy, is the ability to deploy future distributed energy. So when we have pockets of problems, we can look at, is it cheaper to put in a small storage unit here or there to solve the constraint versus upgrading all the distribution system? We'll have data now through this project to say this is the best path forward for this problem or that problem. We'll have controllability, we'll have the infrastructure, the communication infrastructure, the control infrastructure to optimize all those systems. And the software layers that we're getting here are going to serve us.
That's all based on the controller application. That's gonna be very complicated and also very expensive.
That's why we're getting it paid for.
Well, that's why, I understand all that. It works according. The other caveat of this is that you have one fuel source. You have a turbine, which is natural gas. So in other systems, there's more flexibility with fuel diversification. So I wonder how you're going to handle that if the turbine basically, and they all have life expectancy, they're a jet aircraft. The maintenance, obsolescence, you're going to have a new turbine at some point in time as you accelerate the potential use, especially when you get into black start applications and that type of thing. So how do you feel about the fact that you're having one whole fuel source at this point in time?
Then we've had that one fuel source for quite a while. This adds diversity now. We have a battery that's capable of coming online instantly versus the gas turbine that takes 15 minutes. So we'll be more responsive than we've ever been with the system. And over time, as those other fuel sources, as hydrogen comes into play, like that's definitely something that this still works with. This doesn't lock us into natural gas forever. This is an add-on to a generating station, to a system, right? It's flexible.
Well, that's
If
the
we
whole.
get a new burner,
I mean, I think that the NISO calls what you're asking about, what Dennis was asking about, is dispatchable, emission-free resources, right? And so as the New York ISO has looked at the Climate Act and looked at the next 15 to 20 years, they realize with fossil-free retirements that there's got to be new technology that comes in that is emission-free. But it's either not invented yet or it's not commercially proven. And so in parallel to this and many other things we had going on, we're continuing to look at and talk with people about what are our options, right, on the other side of natural gas. But I don't think anybody else has found that solution yet either. That's why the New York ISO calls it an acronym of something that doesn't exist yet.
Well, that's the downside of the blue state. If you follow through on the Trump philosophy, and that is bothersome in some respects because the electrification emphasis in New York State hasn't really put in line with the projected cost and the longevity, the sustainability of all of this, whether it's the grid or what you can do or what somebody's going to buy in terms of appliances and can afford, et cetera, puts on a greater burden on the whole electric distribution system. So I guess my point is and I'm sure, you guys are quality people in terms of what you've done and backgrounds. No question in my mind about any of that. It's just that I wanted to focus on the potentialities and the costs associated with unknowns like in New York State. And that's a problem as I see it. I think that's the biggest problem as the federal government is of maybe denying you a fraction or some of the money in terms of what the ultimate outcome is. The other thing I wanted to point your attention to, I don't know if you know of this or not. Are you familiar with Cummings Power Integrated Center? Cummings has in Minnesota has put together a state-of-the-art microgrid evaluation platform. I can send you this to go online and you can go there yourselves. What they will help you do is to model your microgrid application on site. They have all the instrumentation, they have everything there, have a microgrid in point. Some of it's for industrial applications, but it's also for utility applications as well. So Cummings, of course, were related directly to it. They have this. It's been in operation since 2022. So I would encourage you in the design application phase to go there. It's in what, Frigley, Minnesota, but you can find out. Go there and enhance yourself with what they have to offer. That might resolve and also help you to better understand what this application is going to be on a community scale basis. So that's out there.
I also mentioned we're going through a study right now through NYSERDA, completely separate and unrelated to this project, but looking at the expansion of the distribution system and adding load, forecasting the added load caused by electrification. So we are also working on modeling that and predicting where that load is going to be in parallel with this. That's also another thing to do. This tonight was just mostly about the microgrid, but we are doing a bunch of other things.
Well, it's all related. I mean, it's all definitely defining what your whole purpose is behind this, is provide both secure, stable utility resources to your ratepayers over a long period of time. It takes decades to build an electrical system or any system. And the investment in that takes a lot of forethought and mindset. My questions are only to make the system better. Not to put adversity here. You know, do I want you to succeed? Of course I do. I mean, the economic part of this is huge. There are companies out there that specialize in microgrid development, like Schneider Electric, who's big involved with defense contractors. So there's a lot of stuff there. I would hope local contractors would have the ability to cooperate that. But I think what's needed is what was proven earlier in district heating. Nobody had the ability. That's why I brought in John W. Danford out of Buffalo to become pipeline installers, because nobody knew how to do uphill, downhill welding techniques with thin wall pipe. So I would encourage you to embrace somebody who has actually done this somewhere else rather than try to do it by yourself.
Yeah, and the beauty of a federal contract is everybody knows about it. So they call us.
If you get everything in place.
They already called us. The second we got selected, it was a flood of phone calls from every contractor across the country. That it's been. We just have a flood of emails. People who have done it, will do it.
And who we talked to.
How much of this is still going to be, are you thinking it's going to be contract list?
Initially, a lot of it will be contracted. The underground work initially will be contracting out to do the underground, the excavation, the installation of the conduit, potentially running the high voltage lines, depending on how much it is and the timing of that. There will be some secondary work, with the distributed DER. We're going to hire a contractor to do the electrical portion of that. The engineering firm is the first phase. There'll be a third-party engineering firm, owner's engineer to advocate, and then we'll be hiring the components. So there'll be in-plant work, there'll be out-of-plant work, there'll be PLC work and stuff like that.
And there's Buy American clauses. So.
Do we have online?
I do have an online question. Do you intend to utilize construction teams for the project, or will part of it be contracted out through the bidding process? So I think you answered that pretty much.
Yeah, we'll be publicly bidding all the main steps. So there'll be an opportunity for everybody locally and regionally to come out.
And to answer that question a little bit more, we've actually taken tours of a couple of vendor sites with American Microgrids. So we are actually educating ourselves. People that actually know what they're doing.
Well, that's important, of course, no question about it. You did that with, you guys went to Denmark. I never had the opportunity to set the mayor and general manager there, but that's a great step to, play off what's going on. But I really would encourage you to check out the Cummings. I should sport it. It's PIC is the acronym for it. But I went into it a little bit, and it's pretty amazing. I mean, they got everything you want there.
Yeah, we'll definitely check it out.
Ellen, any more?
No other questions, just people coming in and out. So.
Anybody else?
On the latest, the federal judge put a temporary pause on implementing Trump's freeze till February 3rd.
I think it's all on the social welfare programs.
You know,
Careful of DOE.
They basically applied everything based on it. Big pause.
Be careful. That's all I said. Be careful.
Well, I think we're being careful. And I don't think that anybody that we've met in the last 2 days knows what's going to happen in the next month, 2 months, or 3 months related to this. So we'll manage through that. I know we're going through this with our eyes open, but we've got a lot of people giving us feedback and input as to, what are the impacts expected to be. But I'm just hopeful that at the end of the first quarter, we can submit for a reimbursement and get it, and then we have some confidence that we can continue to move forward. But it's not like we're going to spend a bunch of millions of dollars in the next month.
How much you just spent up to now?
Not a lot.
Yeah, just your time with the DOE, right?
Yeah. Part of it's
Really
not,
not.
it's unpaid overtime.
I mean, I think we're planning for a cable bid, but not soon. We're talking about an RFP for an owner's engineer. That process can play out without a lot of costs being incurred. So I think we're being super cautious right now, but we're continuing to plot forward with more of our in-kind hours.
I think our biggest cost was the print cost for the meeting notification thing.
And, the cable's important too, because we'll start with that, and that's stuff we need to order anyways, so.
And we have a very open line with the DOE staff right now. Like I can give the guy a call probably right now. We're able to ask very open questions. What's happening? What do they think? Obviously you gotta sit here or something writing down.
Well, there's a microgrid conference in April, a big one. And I bet in that period of time, things will probably be shaped out, so we can attend that, go from there.
Yeah, but we're really excited about the project. I think it has many positive impacts. So anytime you want to reach out and ask questions, please do. But again, appreciate you being here to learn a little more about it.
Well, I appreciate the effort that you put into this already, and also the ability to have some community involvement. Without that, I think it's kind of what seems to you guys talking to each other. And that's not always the best way to learn from doing something, is having some input. Sometimes it's good, sometimes it's bad, but nevertheless, it's input.
Yeah, no, appreciate that. The worst part of having meetings like this is if nobody shows up. I think that, maybe it's easier for some individuals to do it virtually, but really appreciate you coming in person. It means a lot.
One of the things I can just add on to that if I can, I think if the utility had a community dialogue on all energy issues, especially as you foresee investments in homes and also efficiencies, equipment, appliances, what's going on. I've also advocated strongly for the utility to actually build a small profile electric house that's all electric, that is possibly be shown for people what it would be, then that could be auctioned off for sale. So that you have a demonstration rather than presentation. So something like that, I think, would help.
So Ellen has an update on that.
I just want to tell you that the city, not just the BPU, but the city in partnership with the BPU had gotten a grant, almost $1 million from the EPA over a year ago, to do up to 12 homes, to do just what you said, Doug, to fully electrify them, to use those as demonstration projects, and then to sell them to hopefully first-time home buyers. These are all homes that are in deteriorating condition in the city of Jamestown, but savable. The Department of Development has targeted those along with the Chautauqua Land Bank. And so work has started on that. It's very exciting.
I've visited all those, and I had some construction problems with them. But anyway, I guess that's all good. But I'd like to see a new modern prefabricated house that is built with all the design ramifications that can utilize your utility attributes. And then ultimately that can be a walkthrough with the appliances and everything else that's necessary for the future. I mean, retaining old houses is a nice thing, but building new ones is even better.
Definitely keep a lookout for that, but fly up for that. Thank you all.
Thank you.
Thank you.
We get it.
Yeah, it was good. Yes. Yeah, sure.
It is.